Hello, good afternoon, good evening, good morning, everyone. So today I'm going to present my paper poster category, local group-based, fast, efficient, and accurate federated learning. It's a review of local group-based federated learning. So this paper is co-authored with me, Ajit Kumar and Banjan Choi. So we are from Sonsai University, Seoul, South Korea. So this is overall structure of my paper. I will be giving a brief introduction about my paper, and then I will present background and related work. Then I will talk about centralized federated learning. Then I will talk about local group-based learning, and then I will discuss conclusion and future direction. So federated learning solve data scarcity problem in machine learning because it's promised to grant privacy to data owners, so that will encourage lots of data creator or source data producer to share their data for machine learning. So that's one of the promising that federated learning is doing. Second, federated learning is a distributed machine learning architecture. So this differ in a distributed way that earlier distributed machine learning were mainly aiming for fast computation of model and other thing, but in this distribution it's mainly aiming to have a privacy preserving machine learning. So it's again collaborative learning also, because there are many participants in the architecture that come together to build a model, so it's a collaborative learning. So federated learning mostly work have a 5-step architecture. So first step, they start selecting participants from pool of available participants. So there can be lots of participants, and then based upon some selection mechanism, participants will be selected for taking participation in the training. Then in a centralized or any learning, a global model will be shared. It can have a train on the some initial data, or it can have a randomized weight, so that initial model will be shared to all the participants to start improving or updating the model. Then second, all the selected participants, that they will hold their own data, and they will do a local training on their own data, and then update will be sent to the server. So that is the third step. And then at the fourth step, the control server will be taking all the updates and then aggregate for a global model. Then global model will be shared to all the participants, or other than outer participants also, depend upon many other policy. So from a step first to 4, almost, or you can say first to 5, almost all a step can be repeated. Mostly we do with 1 to 4, where we have, once we have a good model with good accuracy, then that is shared with the client or any intended user. So for a step. So based upon topology, there are different kind of federated learning, like centralized federated learning, decentralized federated learning. It depends upon how the model is shared and who is controlling the federation. So that's depending upon that we say it's topology, and there are 5 type of topology. So this is federated learning. So we can divide into centralized federated learning or decentralized federated learning. And then under decentralized, we can have horizontal decentralized or vertical decentralized, where we have a layer kind of thing. So that we call decentralized. So in this paper, we make contribution, like we give a conceptual definition of local group-based federated learning, which is novel, which will help to organize the literature on the non-centralized federated learning approach. We also provide a taxonomy based upon federated learning for client topology and other controlling server position and the aggregation level. Finally, we organize and provide a summary of centralized and non-centralized approaches and their challenges and benefit. So this is some of the literature work that is very similar to local group-based learning. So it can be explicit or implicit grouping, or there are many different purpose of taking all many few participants together. So based upon that, there are some work have been done earlier. Mostly they have done grouping for edge computing and other architecture. So you can look into paper for more detail. Then observation, based upon this literature survey, what we observed that grouping improve the performance and decrease communication and computation cost, and reduce the impact of non-IID data. So grouping providing lots of benefit in federated learning. And then Such results are very encouraging to give a hope that local group-based learning is useful in addressing the inherent challenge of central federated learning. So in central federated learning, a server initiates the training and perform all the steps from client selection to final model sharing. So that is centralized, centralized. There will be one server. So suppose, for example, one of the popular example is Google Keyboard. So where Google control the federation and all the handle or smart devices that are participants. So selected participants are chosen by the server to make federation and training. So that is the centralized federated learning. So there are 5-6 steps in federated learning. I have broken down some of the steps further to make it more clear to discuss. So client selection, this is the first step if you remember from previous slide. So what are the challenges in centralized federated learning? So in client selection, we can have malicious clients. So some client intended to do malicious update to the model. So that's the one of the challenge. Then some big clients are there. So big clients means clients having a low number of data or power or computation. So these all make a big client. So again, centralized, every participants are treated equally. They are also expected equally contribution. So that's create big clients. So then heterogeneous clients are also there, like there can be different kind of computational and architecture kind of clients can be there, and that's all complicate the centralized federated learning, and there are algorithms to handle some of this. But we'll see most of this discussion like group based. When we group the client, then many of this can be solved, like we can have trust based grouping where malicious client can be filtered out at the initial stage in the when we are forming the group itself. Then big client also we can address when we have a local group based learning, and then heterogeneity can be also addressed with grouping. Then initial global model sharing and centralize the what kind of model you are using, and then we share one model to every participant. So there is lots of communication cost if we are thinking as a some participant as a group and then sharing only once. Similarly, we can also have to collect the update only once, so there can be lots of reduced cost between the participants and the server. Yeah, but we have to think about the privacy and the promises of federated learning also. So when we are forming the group, we should be considering that. Local training. So local training, when individual nodes are doing, there are lots of challenges. Some of them are like class labeling, how the participants will label, dataset diversity, and then training time. Different, as I say, heterogeneous client will be there, so there can be different kind of computational capability, and then training time will also vary. Compensation and risk innovation is also possible in centralized, and if you look at this, many of this can be solved by grouping of the participants. Then update and gradient sharing also, like dropouts. Some participants drop out between during training, so that can affect the accuracy and performance of the model. So when we are thinking as a group, then dropout can be also managed. Size and quality of update, size will also reduce and the quality of update will improve when we have group based. What we are listing here, it is centralized. These are the challenges, and if you look at from grouping based upon this point, then grouping is solving completely some of the issue, or some of the issue can be improved. So security of update can be also achieved. Aggregation, malicious server, malicious client update or aggregation delay, these are the challenges of centralized learning. Some of them can be solved by grouping. So malicious server can be also like addressed if you have a more small groups, then the server can not know like which data is coming from which participant, because then participants will become as a group. Again, sharing update and global model is like compensation, how you will give individual compensation or group, that's a challenge. So in this group based learning will not be that much capable, but that can also help to, and size of model, of course, it will be handled when we are doing grouping. Then similar all this step that I have mentioned, it can be also in group based, local group based learning, and some of this problem can be addressed by local group based learning. So that's what we have presented in the paper. For more detail, you can look into the paper. So conclusion, as a federated learning, we can achieve high accuracy, lower communication and computational cost, and fast convergence also. Then we have also done a intense research. We also find out that it is there are local group based federated learning work that we try to filter and classify. And then we have also listed some of the key challenges and summarized the federated learning and how local group based learning can solve this problem. And then future direction. So as I mentioned, that efficient method for local group formation. So as I'm proposing a new way of doing the federated learning, and that is local group based learning. So the key will be how we are forming the groups. That is a key research direction. And then how we are managing the training in local group, that is also very important. And then how we are forming this group robustly to take out dropout, malicious client, and other things. So these three will be the key feature direction in local group based learning, and some of the work are also coming. So thank you for your presence. So you can ask any question on this mail, because this I'm presenting virtually. So if you have any further question or collaboration or any kind of communication you want, you can write a mail to us. Thank you.